Hey kids, Mr. Murray here on Mr. Murray's Math Land, back with another exciting algebra lesson on point slope form of a line. I know you guys have been waiting for it, so here we go. Write the equation of a line in point slope form that passes through 3, -4, and has a slope of -5/2, and then we'll sketch its graph. Or you could sketch it right now if you really like. But the big thing here, point slope form, that's a new way to write the equation of a line. And here's what it is. If you're given a point, x1, y1, so you only have one point and you've got the slope, m, then the equation is y minus y1, y minus the y coordinate of your point, equals m, your slope, times x minus x1, the x coordinate of your point. And it really just comes from the slope formula. If you cross multiply, you get this equation right here. So here we go. It's really very easy. A lot of people actually prefer this in upper levels because you write so many equations of lines, but it's a little unfamiliar right now, so I understand if it's a little weird and you're a little hesitant to use it. So here we go. It passes through 3, -4, and has a slope of -5/2. So the beautiful thing about point slope form is you only need the slope and any point that's on the line. It doesn't have to be the y-intercept, like slope-intercept form. It can be any point. So 3, -4 is good. So here's my equation. Ready? It's going to be very easy. Y minus, here's your y coordinate, and here's your x coordinate. I guess I should just call it x1 and y1. This is only one point. So y minus -4. Now y minus -4 will become y plus 4 equals the slope, -5/2, times the quantity x minus my x coordinate, 3. And done. That's it. You leave it like that, and that is point slope form. And a lot of people, they feel a little uncomfortable leaving it that way, but that's actually it. And as far as graphing it, well, here you go. 3, -4, 3, -4, put a point there, and then use the slope. So we're going to go down 5 and to the right 2. That's what a slope of -5/2 is, right? Rise over run. Down 5 to the right 2, and if I go down 5, I'm going to be way off the graph and not be able to accurately do it. So I'm going to go, instead of going down and to the right, I'm going to go up 5 and to the left 2. That's like putting the negative with the 2 instead of the 5. So up 1, 2, 3, 4, 5, and to the left 2. I'll put a new point right there. And if I wanted to do it one more time, 1, 2, 3, 4, 5, and to the left 2, would put me right about there. And here we go. Draw our line. And there we go. Got a little off track there, so let me just, there we go. Better. Okay, so there we go. There's our equation. Very nice. Point slope form. Piece of cake, right? So let's just see one more example with this. And we're going to take on a different problem, an old problem here. Write the equation of a line that passes through 8, -1 and -4, 5, and we're going to express it in point slope form. And then slope-intercept form. Now we've done this in slope-intercept form a number of times, but point slope form, you need the slope. So here we go. Let's get that slope first. If you have 2 points, finding the slope should be a piece of cake, right? y2 minus y1 over x2 minus x1. Remember, if you want to label your points to keep things straight, there's what we're talking about. And now we simplify that. 5 minus -1 is 6 over -4 minus 8. That's -12. And a positive divided by a negative is negative, and 6/12 reduces to 1/2. Okay, so I got my slope. It's -1/2. And for point slope form, like we've said, you only have to have one point that's on the line to go with your slope. And I've got 2 different points. Doesn't matter which one you use. So if you want to use 8, -1 to go with your slope, then your equation is going to look like this. y minus that y coordinate, so minus -1 will become +1, equals the slope, -1/2, times x minus the x coordinate of 8. Stop and you're done. If you use the other point, your answer is going to look different, but they're both equally acceptable. So if you used -4/5, then your answer is going to look like this. Y minus the y coordinate of 5 equals -1/2 times x minus -4. So x plus 4, done. So either one of these would be an acceptable final answer for part A. For part B, slope-intercept form, now we've done that, and one way to do it is the way we were doing it, last week, which is, slope-intercept form is y equals mx plus b. You already know the slope is -1/2, and you can plug in one of the points to solve for b. You can definitely do it that way, so here's a quick review of that. Right, I know my equation looks like this. I already calculated the slope in part A, so I don't need to redo that. So y equals -1/2 x plus b. And if you pick one of the points, doesn't matter which one, so maybe I'll take that 8, -1, the first one, why not? And I plug in -1 for the y and 8 for the x and solve for the b that will make it true. So this is -1 equals -1/2 times 8 is -4 plus b. Solve for b by adding 4, and you get b is equal to 3. And so your final answer is, of course, y equals mx plus b. So y equals -1/2 x plus 3, which is the b value I found. So we're definitely done there. That's perfectly good. But just to show you what you could do is, rather than take the approach we did where we plugged in and found b and then have to rewrite it with that b in place, rewriting it with the +3, you could have taken one of our equations from part A. So let's just say that same y plus 1 equals -1/2 x minus 8. You could take this and just solve it for y, get y all by itself to put it in slope-intercept form, make it look like y equals mx plus b. And we would do that by distributing the -1/2 to clear the parentheses. Right? There's no parentheses in slope-intercept form, so that will give you -1/2 x. -1/2 times -8 is +4. And then to get y all by itself, to isolate y, subtract 1 from each side, and you have y equals -1/2 x plus 3. Same answer here and there. Does not matter how you get there to me, just like to show you that you've got options. This second way is actually a little bit faster, but it's the way you're less comfortable with, less familiar with, so I understand if you don't quite feel ready to do it that way on your own. But just know, hey, it's cool, it works that way. And if you had grabbed this second version of the line and you distributed -1/2 and added 5, you will get this same exact y equals -1/2 x plus 3. There's only one version of the slope-intercept form, and there's an infinite amount of point-slope forms because you can use any point on it. All right, so hopefully this cleared some things up, and if you have any questions, just let me know. Have a good day.